Hello, my name is Mannar. I am with Romanas Company. I am the technical manager of the bleaching chemicals group of Romanas Company. I have 23 years of experience with the pulp and paper industry and more than 10 years of experience with the recycled paper industry, both newsmag, OCC and mixed office waste, newsprint recycling, tissue recycling, and also liner board recycling mills I have worked for startup, optimization, and also guarantees of the process. Today my presentation is based on recycled fiber bleaching overview. Over the years, the quality of recycled fiber is declining. The recycled fiber contains higher amount of outthrows, prohibitives, higher amount of color, and also higher amount of groundwood pulps. Today's recycled mills are faced with the challenge to make virgin fiber quality targets like 85 to 90 brightness from the recycled fibers, and also they go through environmental pressure to go for environmental friendly bleaching. So in my lecture today, I am going to focus on fundamental principles of recycled fiber bleaching. What are the learning objectives of this course? First, we are going to identify the bleaching chemistry and the bleaching system. Then we are going to look at strength and weakness of the chemicals we are using for bleaching recycled fiber. Then we can look at what conditions we want to bleach. Later on I am going to go through how do we optimize a bleaching process. What are the things to look at? And then how color of a paper and the fluorescence present in the paper, how they influence the bleaching process. Finally, I will give you some guidelines about bleaching of recycled fiber. To do that, I am going to give you some background and bleaching processes, both oxidative and reductive bleaching processes, and process optimizations with respect to consistency, temperature, pH, and where we want to add this chemical, and what are the color and fluorescences, how do we measure color and fluorescence. Finally, how do we bleach recycled fibers to get our target brightness. So let me start with some background. What is bleaching? Bleaching involves elimination of light absorbing substances in pulp, resulting brighter and whiter shades. What's the task of a bleaching chemical? To prevent or to eliminate the chromophores, or also to modify the chromophores that are present in the recycled fiber. This slide here gives you the various symbols used for bleaching chemicals. The paper industry loves to use symbols for denoting the chemical's name. In this case, the letter A stands for acid. The letter B stands for Borohydride, C for chlorine, D for chlorine dioxide, E for caustic extraction, and H for sodium hypochlorite. Sometimes people use the letter F for FAS chemical, Formamidine sulfonic acid chemicals, and also O for oxygen and P for peroxide. The letter Q is used for chelate for fixing the metal ions. The letter W denotes the washing stage between the bleaching stages. Again, the letter hydrosulfite, the letter for hydrosulfite is Y. It is the second letter of the hydrosulfide word, because H is already taken for hypochlorite. Same thing true for ozone. The letter Z is taken the second letter to represent ozone. So if somebody comes to you and say, in my mill I have PY bleaching, that means I have a peroxide bleaching followed by hydrosulfide bleaching. If somebody says, in my mill I have CEH bleaching, that means what you have is chlorine followed by extraction and then hypochlorite. Same thing, CED is chlorine extraction and chlorine dioxide. You got the picture now how the bleaching group represents their bleach chemicals with the letters. Now let's take a look at fundamentals of bleaching. I have divided here brightening, delignification and brightening, and color removal. What is brightening? If we take mechanical pulp, there we are modifying the chromophores without losing the yield. So the mechanical pulps are bleached under the condition called brightening. In the case of chemical pulp, they are bleached under the condition called delignification and brightening. Both are happening in chemical pulp bleaching. But in the case of recycled pulp, it's much more challenging because we need to do one more additional function, not only brightening and delignification, but also we need to do color stripping. Recycled fiber bleaching is really challenging because this has chemical pulp, mechanical pulp, and once bleached pulp, and also some brown fiber from OCC, old corrugated containers, are present there. And not only that, we have dyes, pigments, fillers, fluorescent whitening agents. All these components make this really challenging. So now let's take a look at what is a brightening process. In brightening, this is for mechanical pulp bleaching. Here we are modifying the chromophores on the lignin structure without losing the yield, without removal of lignin. In other words, it is called lignin preservative bleaching. The chemicals used for this purpose is hydrogen peroxide, sodium hydrosulfide, and sodium borohydride is widely used to make sodium hydrosulfite to bleach mechanical pulps. The next one, let's take a look at delignification. This pertains to chemical pulp bleaching. What we are doing here is the residual lignin that comes out of the pulp after the digestion process with caustic, it's attacked by oxidative chemicals for the removal of lignin. Here we are removing the lignin, we are going to lose some yield. So the removal of colored lignin from fiber with yield loss is called a delignification process. Now let's move on to decolorization process. Here what are we doing? We are chemically reacting with added dyes or components in pulp to change color and also to remove them from the system. The colors are added to the paper to make color papers. Like this particular sample here, this gives you some pink color, some blue color, some yellow color. This is a printed yellow color. These are all typically recycled today. These are chemical pulp dyed with color paper, color dyes. Okay, that's what we want to make it white. This is decolorization. Then chemical works on it and make them white. The chemicals typically used for decolorization is sodium hypochlorite, Formamidine sulfenic acid, sodium hydrosulfide, hydrogen peroxide, and sodium borohydride. Here is a picture of mixed waste or mixed office waste paper. As you can see here, those are the bales of mixed office waste. It contains office paper, typically Xerox and laser type printouts. And these type of paper you typically generate in your office place. Right here is a Xerox paper and is a laser printer here, and these are the papers present here. And also you have OCC, old corrugated container boards, brown fibers. Then you may have some newsprint in this paper mixed in. That's a newsprint paper. This is how it looks like. 58 brightness there. And then there may be some magazines like this, with a high amount of ash and glossy shining magazines present in this paper. We need to recycle all this and we need to bleach it to make a nice bright white paper. How are we going to do it? That's what you are going to see in my presentation. There are three types of recycling. To make a newsprint, what you need to do is to recycle newspaper. Sometimes these newspapers are mixed with old magazines. So, newsprint mixed with a magazine, 70% of newsprint typically mixed with 30% of magazine, or sometimes 80-20 or 90-10. Even I have seen recycle plants recycling 100% newsprint to make newspaper. Again, you need to go through de-inking, color stripping, delignification, all kind of processes, particularly lignin modification process, to get to 58 brightness again. The second type of recycling is called mixed office waste or office waste recycling. Mixed office waste contains high amount of laser and Xerox printouts like I have shown here, and also various color paper. These are present in that. That is why it is called mixed office waste. This is recycled to make tissue and towel grades and also writing and printing grades paper. The third type of recycling industry is called to make liner board. You recycle pizza boxes to make box board again. And medium and liner grades are made out of old corrugated containers. So, we know there are three products: newsprint, printing and writing, and liner boards and mediums. And three types of raw materials we recycle: news magazine to make newsprint, mixed office waste or office waste to make tissue and printing and writing grade, and also OCC to make liner boards. Now, let's take a component of these papers. Take a look at the components of these papers. ONP stands for old newsprint, OMG stands for old magazine, MOW is mixed office waste, OCC is old corrugated containers. Here we have mechanical pulp, bleached chemical pulp and unbleached chemical pulp. ONP, old newspaper, it contains 100% mechanical pulp. OMG contains 80% mechanical pulp and some amount of bleached chemical pulp in the magazines. On the other hand, mixed office waste contains very little mechanical pulp, very high amount of chemical pulp. But these chemical pulps are dyed with dyes, colored paper. OCC is mostly unbleached chemical pulp, and there are also some bleached chemical pulp present in this as a top liner. Once you divide your raw material in this form, then you know what type of chemical you need. For example, in the case of ONP and OMG, magazine and newsprint, because it contains high amount of mechanical pulp, what you need here is lignin preservative bleaching or brightening chemical like peroxide and sodium hydrosulphide or sodium borohydride based chemicals. In the case of mixed office waste, you have a lot of dyes. It's all colored paper right there, 90%. So, you need a chemical that can decolorize these colors, that can attack on dyes and remove those dyes. In the case of OCC, you have lignin, and you may need some delignification chemicals to remove the lignin to make it brighter and whiter. Now, let us take a look at bleaching processes and how do we classify these bleaching processes. There are two ways you can classify the bleaching process. One way is chlorine containing compounds and chlorine free compounds. Chlorine containing bleaching consists of chlorine, chlorine dioxide and hypochlorite. Chlorine free bleaching is peroxide, oxygen, ozone, hydrosulfite, FAS, formamidine, sulfonic acid and sodium borohydride. This is totally chlorine free bleaching. There is another way you can classify these chemicals called oxidative bleaching and reductive bleaching. The oxidative bleachings are chlorine, chlorine dioxide, hypochlorite, peroxide, oxygen and ozone. The reductive bleachings, sodium hydrosulphide, formamidine sulfonic acid and sodium borohydride. So, this is how the bleaching chemicals are classified. Now, where in the process we do the bleaching? In the recycle process. If it is a newsprint furnish, let us say to make newsprint we are recycling this. Newsprint goes into the pulper, there is small amount of peroxide is added here to prevent alkali darkening effect. You add caustic there, you do not want caustic to yellow with the lignin your paper, so you need some peroxide there. Then go through the demptures, coarse grain, fine grain, screw press. When you go through this process, what is actually happening is, here the consistency is 10 to 15%, you are going down to 4% consistency, and then coarse grain 3% consistency, fine grain you are doing 1% consistency, now thickening back again to 35% consistency in a screw press. So, this is called first loop. All the water dewaters from the press goes back to the pulper. So, right here the consistency is 35 and goes through the disperser. In the disperser, the fiber rubbing action works on the ink and breaks the ink's particles. So, there is a good mixing of fiber takes place, and you need to put energy into it, 3 to 4 hours per days per ton. Energy goes into the disperser. When you put energy into the fiber gets heated. So, it is a high temperature available. There is a good mixing, higher consistency, high temperature, these are all available. It is ideal for peroxide type bleaching. So, you add peroxide chemical in the disperser. Disperser is used as a mixing device, and also temperature and consistency helps, then send through a retention tower where you have the oxidative bleaching takes place. Now, right after the tower, your pH will be somewhere between 8 to 9, which is ideal for flotation, and then after flotation you do the dewatering and thickening again with the washing device. Now, it is 10% consistency and the residual peroxides are removed, it is ready for reductive bleaching. Here you can use, in the reductive bleaching, you can use hydrosulfide or sodium borohydride or FAS chemical for bleaching here. And then you come out at a pH of neutral between 6 and 7, thickening process and goes to paper machine. So, oxidative bleaching first, followed by reductive bleaching next in the de-inking process. Now, I am going to move on to various types of oxidative bleaching chemicals. Chlorine, chlorine dioxide, hypochlorite, those are all chlorine containing compounds. Oxygen, peroxide and ozone are total chlorine free compounds. I am not going to spend a lot of time talking about chlorine, chlorine dioxide and hypochlorite, because very rarely they are used because of the environmental pressure. When you use chlorine, chlorine can react with fibers and lignin, and there is a possibility of forming chlorinated organic compounds like dioxin. The health effects of dioxin is still debatable. So, the environmental group has reduced the usage of chlorine or chlorine containing compounds. That is why TCF, bleaching chemicals like peroxide, becomes very popular for TCF bleaching, total chlorine free bleaching. I am going to touch a little bit on sodium hypochlorite, because some of the mills today still use hypochlorite in the pulper for color stripping purposes. Hypochlorite is made with the sodium hydroxide, reacts with chlorine, then you get sodium hypochlorite. This sodium hypochlorite bleaches the dyes, attack on the dyes and decolorizes them. The charge I have seen for mixed office waste all the way up to 2.5%, Consistency typically 5% to 12%, ideal for medium consistency pulpers. Very economical chemical, you can add in the pulper and bleach it. Reaction time short, anywhere from 30 minutes to 90 minutes. And temperature, room temperature 35 degrees C to 70 degrees C. So it works very well for pulper bleaching. Again, you need a higher pH, 9.5 to 11 for hypochlorite ions. Below 9.5 pH, you have hypochlorous, which can attack on fibers. So you need to be at a higher pH for getting maximum strength out of your fibers. Where do you apply hypochlorite? You don't want to apply hypochlorite on high lignin fibers like newsprint. When you have a high lignin fibers, when you apply oxidative chemicals like chlorine or chlorine dioxide, the kappa number of these fibers are much higher than 100. So the lignin will start bleeding. It will make the fiber yellow. So what you need to do is avoid hypochlorite or chlorinated compound bleaching on newsprint. It's very popular for bleaching office waste. You can do pulper. In the pulper you can add hypochlorite, or in the dispersion where you have nice consistency, you can add hypochlorite there. Most popular is inline or any tank or tower bleaching with sodium hypochlorite. What are the advantages and disadvantages of sodium hypochlorite? It's very easy to use, very effective, and it's an excellent chemical to remove fluorescent whitening agents. If your mill is making food grade, food contact grade papers, for example pizza boxes, inside it's a white liner, you don't want fluorescent whitening agent in that paper because there are some health effects associated with that. So there is a standard FDA has given for amount of fluorescent whitening agent that can present in the paper. Hypochlorite and any chlorine containing compounds are excellent for reducing the fluorescent whitening agents. What are the disadvantage? The dioxin issue. It's still there. Environmental group is going to put pressure on you. And pH 4 to 7 hypochlorous acid going to degrade your pulp strength. The next most commonly used chemical is peroxide. I want to spend a little bit more time on peroxide because it's most popular chemical used by the recycle group. Hydrogen peroxide in the presence of caustic gives perhydroxyl ion. That's a bleaching species. Also hydrogen peroxide in the presence of air or in the presence of metal ions or at high temperatures can decompose to water and oxygen. There is also an enzyme called catalase. These are present in the newsprint recycle industry. In their white water, these enzymes can decompose peroxide to water and oxygen. So we need to worry about metals. We use a chelating agent to fix the metals. We need to worry about enzymes. We need to get rid of the catalase for preserving the peroxide, so peroxide can work on your fibers and bleach the fibers. Typical charge 1 to 3%. Consistency peroxide, higher the consistency, better it is, because the concentration of peroxide will be higher at higher consistency, and the perhydroxyl ion can reach that fiber at a higher concentration and attack on that fiber and make it brighter. Reaction time anywhere from 30 to 240 minutes. Temperature and reaction time goes with together. Higher temperature you need lower time, or lower temperature you need higher time or longer time. pH of peroxide bleaching typically between 9 and 11.5. Above 11 the perhydroxyl ion content is low. Below 9 also perhydroxyl concentration is low. So between 9 and 11 this concentration is at peak, so you get a good bleaching out of it. Here is the peroxide bleaching system. Peroxide bleaching process is helped or aided by additional chemicals. First is a chelant. I explained to you the metal ions. Recycled fiber contains iron and manganese, aluminum, calcium, all kind of metals comes with the recycled paper. Some of these metals, manganese and iron, can work on peroxide and decompose the peroxide. So we want to fix the metal first. So what you do is you add a chelate, DTPA or EDTA, you add to fix the metal and complex the metal. So they don't attack the peroxide and take away your peroxide. Caustic is added at a particular ratio to peroxide to maintain the initial pH so that I can have optimum amount of perhydroxyl ions. Sodium silicate has multi-purpose. It is a stabilizing compound for peroxide. It is also dispersant. It also helps fixing the metal ions. So caustic, chelate and sodium silicate, all three are added here. This is called peroxide soup. It is added to the pulper first and then you add the peroxide next. It is at the right pH. So when you add peroxide there with a high shear mixture, it's mixed and then it goes into the downflow tower. In bleaching, we talk about two kinds of towers for fiber retention. One is called downflow tower, the other one is called upflow tower. In the downflow tower, the fiber flows from top to bottom. In the upflow tower, the fiber goes from bottom to the top. Upflow towers are very useful if you have oxygen bleaching, gas phase bleaching, or if you have reductive bleaching where you don't want air to contact. So you don't want to drop the fiber freely into the chest. If you drop the fiber from top to bottom, it can contact air and it can eat your reductive chemical. And also if you are mixing with oxygen, you are dumping from top to bottom, oxygen can go away and stay in the top, so you won't have efficient mixing. So there you use the upflow tower. Where you use downflow tower? For peroxide. Here after mixing, you can just dump it. The chemicals are intact with the fiber. It goes to the bottom. You are putting in at a consistency of 30-35%. Here white water is added to dilute to 10% consistency, and the fiber is conveyed in this conveyor at 10 to 12% consistency. More white water is added to drop the consistency to 5% into this tank. This tank, you need to have some amount of residual peroxide. Why do we need residual peroxide? Let's imagine we consume all the peroxide in this tower. We are bleaching at a pH of 10.5 at the top. So I have some residual caustic at the bottom of the tower. This residual caustic, if you don't have peroxide, it's going to react with your additional lignin or residual lignin there and going to make it yellow. So you have to ensure some peroxide is present there, so it is not darkening your fiber. Typical value 5 to 10% residual peroxide that can be present in this tank. That means you have a good bleaching going on when you have some residual peroxide there. You didn't do the alkali darkening. Now the next stage of my bleaching is reductive bleaching, but if I let it go without neutralization or without taking the residual peroxide, peroxide is an oxidative chemical. It can go and eat your reductive chemical and it can waste your reductive chemical. So the next important step in peroxide bleaching is what we call neutralization or souring of peroxide. Typically SO2 water, sulfur dioxide water and sodium bisulfide chemicals are used for neutralization purpose to reduce or to get rid of the residual peroxide and also to get rid of the residual alkali. Here is the residual peroxide souring process. Still some of the mills, they use sulfuric acid. They think they are neutralizing residual peroxide, but that's a wrong assumption. With the sulfuric acid, what you are doing is you are neutralizing only the alkali. If you look at this equation, peroxide and caustic reacts with sulfuric acid, it gives still peroxide is there, only the caustic is neutralized to sodium sulfate. we did not neutralize the peroxide. This peroxide can go and take away your reductive chemical. So, the right chemical to use for peroxide neutralization or souring is SO2 water. Let us take a look at that. SO2 reacts with water to form sulfurous acid, then peroxide reacts with that sulfurous acid to form sulfuric acid. Sulfuric acid reacts with caustic and neutralizes. So, overall I am getting rid of peroxide, I am also getting rid of the residual alkali present in the system by adding SO2 water. So, SO2 water or bisulfide, those are the two chemicals. Bisulfide functions the similar way of SO2 water to get rid of residual peroxide and residual alkali. For a minute, let us imagine we are not going to neutralize the peroxide. We are going to let it go to the hydrosulfide bleaching. Here the equation, 3 moles of peroxide reacts with the hydrosulfide, and then it produces Na2SO4, H2SO4, and you have water. So, your hydrosulfide is consumed by peroxide. Every pound of peroxide can take 1.7 pounds of hydrosulfide. So, when you are adding hydrosulfide to bleach your fiber, it is not available because the water contains peroxide, residual peroxide. That residual peroxide is going to take your hydrosulfide away from bleaching. So, available hydrosulfide for bleaching is very little. If you are adding only 1% or 1 pound of hydrosulfide, that is already gone and neutralized by peroxide. So, you do not have hydrosulfide to bleach. You may be wondering why hydrosulfide is not bleaching your fiber. That is because of the peroxide taken away the hydrosulfide. Let us look at the various additives used for peroxide bleaching. Chelating agent for fixing the metal ions, otherwise peroxide will get decomposed to oxygen and water. EDTA and DTPA are used for this purpose. Metals come from recycled fiber and also mill waters. We need to fix these metals, that is why chelating agents are used. EDTA is ethylene diamine tetraacetic acid, DTPA is diethylene triamine pentaacetic acid. Sodium silicate, it is a buffer and metal ions inactivation, and also it stabilizes peroxide. So, silicate, chelant and caustic, these are the chemicals that goes with peroxide bleaching, as I explained to you before. Where do you add peroxide in your process? You can add in the pulper for newsprint, or disperser, high consistency, ideal place for peroxide, or typical bleach tower, downflow towers. In the case of office waste, again pulper, disperser and bleach towers. Note here, the peroxide can be used for both newsprint recycle industries and also office waste recycle industries. What are the advantages of peroxide? Very effective with a mechanical pulp, and also you have residual lignin in chemical pulps. Peroxide can take away the residual lignin and give higher brightness. Typically in chemical pulp bleaching, at the last stage peroxide can be used, and it gives that label total chlorine free bleaching. What are the disadvantages? It requires this metal fixing chemicals, chelating agent and the soup that goes with it. So, there are a lot of chemicals you need to handle. Not effective itself on many dyes, and if you have a catalase, an enzyme, if that is present in your white water, that catalase is going to attack on peroxide and going to decompose and take the peroxide away. Then you need to add more and more peroxide, then the process becomes very expensive. Now, let us take a look at oxygen bleaching. This is another total chlorine free bleaching chemical. There is quite a lot of various radical oxygen available, species available for bleaching purposes. Typical charge 1 to 2%, and in a pressurized vessel, the pressure inside the vessel is 60 to 90 psig. The consistency is 10 to 15%. Reaction time can vary anywhere from 5 to 60 minutes. The temperature, you need a very high temperature, 85, even up to 140 for oxygen to work. Initial pH, you need 10 to 11. Therefore, you need caustic to go with the oxygen to raise the pH of your pulp. Here is the oxygen process. Steaming tube to raise the temperature to 80, 85 to 90 degrees C. Goes to high consistency or medium consistency pump. The pulp is pumped here, and then you add oxygen here through a high shear mixture and send it through the upflow tower. Note here, the pulp goes from bottom to the top. That's why it's called upflow tower. The tower is under pressure, 60 to 90 psig. That's why you have the control valve, the blow valve through which the fiber is blown to a blow tank. On the top, you can add dilution water to ease the blowing effect, so it can blow to a blow tank at 4 to 5% consistency. There is a process called OxyPro process by Air Products. There they add a little bit peroxide with the oxygen to help in decolorization process for mixed office waste, and also to help the oxygen delignification of brown fibers when you have a higher amount of brown fibers present in your system. Where do you apply oxygen? You don't put oxygen for newsprint recycling because it's going to yellow the fiber. It's a high amount of lignin present. Oxygen is a good delignification chemical because such a high kappa number on the newsprint. You may bleed the lignin, you may make the fiber yellow. So what you need is a pressurized bleach tower for office waste. That's where oxygen is going, like shown in the previous diagram. Advantages: good delignification chemical. Multi-stage oxygen delignification I have seen for recycling old corrugated containers to make it to bright white grades. From a brown fiber of 40 brightness, you can make 85 brightness white grades using oxygen. 3 stages of oxygen used. Very economical chemical. Total chlorine free label. Works with peroxide, the OxyPro process. What's the disadvantage? You need a pressure vessel. And if you have high amount of mechanical pulp like groundwood present in your system, newsprint, and you are applying oxygen, you can lose quite a lot of yield. Up to 15% recorded in the literatures with oxygen, the yield loss. And whenever you lose yield, it's a higher amount of BOD and COD on your effluent. The effluent loading goes up. The next chemical is ozone. This is again total chlorine free chemical. Ozone is a triatomic atom of oxygen, O3. Typical charge 0.25 to 3%. Above 2.5% ozone, the brightness levels off. Again, consistency 10 to 40% consistency. Very short retention time is needed, 1 to 5 minutes. That's all needed. And very easy bleaching, room temperature, it bleaches. It decolorizes your mixed office waste. Very powerful chemical. pH, it can vary anywhere from 2.5 to 10, but in the case of recycle mills, I have seen 7 to 10 pH works better for color removal. Again, the consistency of bleaching is very important for ozone. At a higher consistency, ozone can directly contact the fiber. If you leave it long, ozone can attack the cellulose, can degrade the cellulose. So you have to be very careful. Let's say people use medium consistency for ozone bleaching so they can have a good control over the chemical and also the strength properties of the fiber. Here is the process for ozone bleaching. Oxygen goes through ozone generator. Here we use a process called corona discharge, electrolysis of ozone or oxygen to get ozone, and it goes through the ozone compressor and goes through ozone ring here. The pulp comes from the standpipe with the MC pump, goes through the ring, ozone is mixed here, and then it goes to a very small short tower because retention time you need is only 5 minutes and it's room temperature, you don't need steam here. Once the ozone reacts and decolorizes the pulp goes into a separator where fiber separates from the gas, the hydrocarbons and some residual ozones are there, and you cannot let that go to the environment, because environmental people will be after you. So what happens is, typically this gas recycled back here to the generator to produce more ozone. There are technology available today to recycle this gas back into the system. The pulp, after ozone bleaching, goes to a tank and then pumped to the next bleaching stage. Where do you apply ozone? Again, no for newsprint. For office waste, using bleach tower, ozone can be used. What are the advantages? Very fast reaction, 5 minutes, room temperature, low temperature, good color removal, TCF label, total chlorine free label. Ozone is the only TCF chemical that can work on fluorescence, FWA, fluorescent whitening agents, and it can reduce fluorescent whitening agent. So you don't need chlorinated compounds to reduce the fluorescent whitening agent. You can use ozone as an alternative chemical to reduce them. If you are not careful, the disadvantage is it may affect the strength. Significant yield loss can occur. And with a mechanical pulp, it can make the fiber yellow because of a high amount of lignin present there. That's the picture of the oxidative. We looked at chlorine containing compounds, chlorine, chlorine dioxide, hypochlorite, and we also looked at peroxide, ozone, and then oxygen bleaching. Peroxide bleaching is the most common bleaching, widely used for bleaching recycled fiber. That's a good TCF bleaching chemical for this purpose. Now let me move on to reductive bleaching. There are 3 types of reductive chemicals: sodium hydrosulfide, FAS, which is a formamidine sulfonic acid, and then sodium borohydride. The process is called a DBI and marketed by Roman Haas company. The process is called direct borohydride injection. That's what DBI stands for, direct borohydride injection. Let's take a look at hydrosulfide bleaching. It's the most popular chemical widely used for bleaching newsprint and mixed office waste. Sodium hydrosulfide reacts with water to form dithionite anions. The another name for hydrosulfide is dithionite. It is also called a hydro. This dithionite can react with dyes or lignin and make them colorless. One of the disadvantages with the hydrosulfide is, as any reductive chemical, with oxygen it can form bisulfide and bisulfate. So your chemical is consumed by oxygen. That's why you need the upflow tower. You don't need the downflow tower. If you drop it, air can contact and take the chemical out. The second thing is, under anaerobic conditions, if your pH is low, then you can create thiosulfate. Thiosulfide is a corrosive chemical, and that can corrode your paper machine wires or parts of the paper machines. If you are using a lot of hydrosulfide, let's say you are using 3% hydrosulfide instead of 2% you need, the excess hydrosulfide going to go to the paper machine. The paper machine, it can work with at a lower pH, particularly if you are making acid paper making process, you are going to drop the pH to 5 or 4.5. So if there is a dead zone in your blend chest or machine chest, it can form thiosulfate. So you have to be very careful not to let the excess hydrosulfide to form thiosulfate. The typical charge 0.5 to 2%. Consistency of hydrosulfide bleaching, it works at low consistency to medium consistency. Reaction time, very short time, 15 to 90 minutes, and temperature 40 degree to 80 degree centigrade. And the pH for virgin mechanical pulp bleaching, it is 5.5 to 6. but in the case of recycled fiber, the pH can be between 7 and 8. It works fine. Where do you apply hydrosulfide in your process? You can apply in the pulper. Roman has a patent called reductive bleaching technology, and you can apply at the disperser with the kneaders and with the dispersing chemical, disc type dispersers. You can add hydrosulfite right there, or in a bleach system, inline bleaching in the pipeline or standpipes, or a tower bleaching like upflow towers. In the case of office waste, you can add at the disperser and again inline, tank and towers. What are the advantages of hydrosulfide? Very easy to apply. It's a liquid form, you just pump it, it goes into your system. Very good color removal. Some of the dyes were completely removed to make it white. And total chlorine free label. And it works on mechanical pulp. So, if you recycle fiber, office waste contains, let us say, some amount of newsprint, hydrosulfide can attack on lignin and also attack on dyes. So, it works on both. Decolorization takes place and brightening, the modification of chromophore on the lignin takes place. What is the disadvantage? Like any other reductive chemical, if you have oxygen or air present, that takes away your chemical. And also if you have residual peroxide, any oxidative chemical, that can go and eat your hydrosulfide. Next reductive chemical used is formamidine sulfenic acid. It is called FAS. FAS chemicals reacts with caustic and it gets activated by caustic. Like any other reductive chemical, it decomposes with the oxygen. Charge typically used is 0.5%, 0.3 to 1% range I have seen. And there are some amount of caustic that goes with every pound of FAS you put in. The thumb rule is if you use 1% caustic, 1% FAS, you need 0.5% caustic. 50% of that is caustic you need. Initial pH varies from 8 to 11. Typical pH is 9, 9.5. Consistency, low consistency to medium consistency, 3 to 12. Again, reaction time, short time, 30 minutes to 90 minutes. I have seen temperature anywhere from 40 to 80 degrees C. Where do you apply FAS? On colored newsprints, there are pink colored newsprints and slightly blue colored newsprints are available. There you can use FAS to get it as a color in the pulper, disperser, inline, tank and tower bleaching. Where it is more popular is for office waste color stripping. For stripping red, yellow, blue dyes, FAS works very well. So, it is again added at the disperser and also inline, tank and tower bleaching. Advantage, it is easy to apply. It is available in powder form. You dissolve it to form a liquid. Sometimes you dissolve it with caustic and then you pump it to the process. Excellent color removal, total chlorine free label, and it is alkaline process. In the case of hydrosulfide, you may have to drop the pH sometimes to get the dyes out. But in the case of FAS, you need a pH of 9. The peroxide bleaching in your process starts with pH 10. After the bleaching, the pH goes down to 9. Now, if you want to follow that with a reductive bleaching step, here is the peroxide oxidative bleaching and next is reductive bleaching. So, 10 goes to pH goes to 9. Now, that is ideal starting point for FAS bleaching. So, at 9 you can add your FAS chemical without changing your water loops. So, it is a natural flow of the pH. Disadvantage, it requires another chemical, sodium hydroxide. Again, like any other reductive chemical, with the oxygen and the air, it reacts and you have less FAS available for bleaching. So, you need a flow tower for FAS. Here is a typical flow sheet for reductive bleaching. Your pulp comes into a standpipe, 10 to 12%. You pump it. Normally, there is a degassing pump attached to this pump to take away the residual air that present in the system. So, the air will not go and take away your chemical. Then you have the medium pressure steam added to raise the temperature. Now, you add your FAS or hydrosulfite into the high shear mixture and pump it up to the tower. This tower, called a reductive bleach tower, in some mills it can be a pipeline from pulp mill to the paper machine. This tank sits in the paper machine side. So, if you have more than 10 minutes, it can be a pipeline. The chemicals are reacting during the time before it goes to high density tower. Reductive chemicals are very fast reaction. 80% of the reaction takes place within 6 minutes. So, if you have retention time here 10 or 15 minutes, that is good enough. All the chemicals are in. So, you can drop from top to bottom. You do not have to worry about air taking away your chemical, because the chemicals are already in the fiber. There you store at high consistency 10 to 12, and then dilute at the bottom with the white water and pump it to your paper machine for making bright, nice paper. The next process is marketed by Romanas company. It is called direct borohydride injection process. Again, it is a reductive process. There are two chemicals involved, sodium bisulfite and sodium borohydride. Sodium bisulfite is a mild reducing chemical. Sodium borohydride is a very powerful, very strong reducing chemical. When you mix these two chemicals, it forms sodium hydrosulfide, and sodium hydrosulfide is a moderate reducing chemical. So, you have a mild sodium bisulfite, moderate sodium hydrosulfide, and powerful reducing chemical sodium borohydride. Now, where do you apply these chemicals? In a deinking mill, it can be applied in the pulper, disperser, or inline, tank, or tower for both newsprint and office waste, for working on lignin or working on dyes. Here is a typical flow sheet for DBI process, direct borohydride injection process. You have a sodium bisulfite solution, typically available 38 to 40%, commercially available, very stable. And here is sodium borohydride solution with a 12% sodium borohydride and 40% caustic. The pH of this solution is 14, the pH of this solution is 4.5 to 5. When you mix these two in a mixture, static mixture, you get a pH of solution 7. Here there are three types of reductive species present: bisulfite, borohydride, and hydrosulfide, because these two react to form some hydrosulfide in this mixture. So, these three reductive species gets pumped into this line, where pulp comes from the decker to the MC standpipe, and the pump is used here for mixing the reductive species with your pulp, and then it goes through your bleaching step, the upflow tower. What are the advantage of DBI? Very easy to apply, because these are two liquid systems. There are two pumps. You just pump it through the static mixture, there it goes. Excellent color removal. Sodium borohydride is very strong chemical. It attacks on double bonds, particularly dyes, and it works on those dyes and removes them. Well, azo dyes. And again, you have total chlorine free bleaching and mechanical pulp, lignin. The hydrosulfide present there that can work on the mechanical pulp and modify the lignin group without the removal of lignin. And three reductive species works if you have high lignin or high amount of color or different types of dyes. Your recycled pulp is subject to variations in these color compounds. So, the three reductive species helps and brightens and gives much better brightness. Disadvantage, like any other reductive chemical, it reacts with the air, and air takes away the borohydride compounds and your reductive species. So, you need upflow tower, you need to make sure the chemical reacts with the fiber. Why people use DBI compared to hydrosulfide or FAS? There are multiple reasons for that. First of all, both are stable liquid. You can put in your mill and it can stay in your tank more than 5 years without degrading or decomposing. Whereas liquid hydrosulfide, if you have a shutdown for more than 3 days, that liquid hydrosulfide can go bad in concentrations. And you don't need a dissolving unit with the DBI. It's not a powder form, you don't need dissolving units, there is no fire hazard associated with the DBI. And domestic supplier, borohydride solutions and bisulfite solutions available here. It eliminates, you don't need caustic. Borohydride comes with caustic. You don't need that here, like FAS chemicals need some caustic. And because these chemicals, both bisulfite and borohydride, are available at higher concentrations, number of trucks coming into your mill is significantly reduced. 30 to 35% reduction in truck traffic. This is perceived to be significant advantage, particularly your recycle mills are in the city. And performance wise, lower application cost, and because of multiple reductive species available, it accommodates wider range of furnish fluctuations or variations. We saw in the reductive bleaching hydrosulfite, FAS and DBI, direct borohydride injection process. I am going to touch upon enzyme a little bit because enzyme also helps in bleaching as a pre-bleaching step. Enzymes are protein molecules that catalyze a chemical reaction. Cellulase, enzymes work on cellulose fibers. Hemicellulase, enzyme work on hemicelluloses, are used in de-inking to ease the ink off. Thereby, it brightens the fiber. It prepares the fiber for bleaching. You need to be careful with cellulases. They report, if you had a lot of celluloses, they can attack on cellulose fiber and degrade the fiber strength. This particular table is extremely important for selecting a proper chemical for bleaching your fiber. On the top, I have various chemicals. C is for chlorine, H is for hypochlorite, D for chlorine dioxide, P for peroxide, O for oxygen, Z for ozone, Y for hydrosulfide, F for formamidine sulfonic acid, DBI for direct borohydride injection process. Here I have various functions of color removal. The brightening step, modification of lignin, delignification, removal of lignin, decolorization, color removal, and fluorescence removal, FWA removal. If you have 2 pluses, the process is very effective in working on that particular process. If you have 1 plus, it is effective, 0 means neutral, negative means not effective, double negative means it is a very negative results you get. It may not even bleach. Again, the comment here is it is a qualitative assessment of a single stage performance only. In other words, just one stage bleaching, not multiple stage bleaching, this table applies. So, if you have a lot of mechanical pulp, you need a brightening process. So, what are the chemicals we can select? I would select peroxide because it is a nice brightening chemical, very effective. Then I can select hydrosulfide, it is effective. Peroxide can brighten virgin mechanical pulp up to 20 points. And use MAG, you can get up to 7 or 8 points with peroxide in brightness. Next one is hydrosulfide, and FAS can also work on mechanical fiber, but not that effective as peroxide. DBI works much better than hydro and FAS because it has got that borohydride compounds. That borohydride can also work on conjugated double bonds, and then it can brighten the lignin. So, there is an additional effect on top of hydrosulfide that present in the DBI process. What are the delignification chemical I can use? Chlorine is very effective. Chemical pulping industry uses typically chlorine as the first stage. And you can use chlorine dioxide for delignification. There is a lot of paper NC State has produced on chlorine dioxide delignification. Peroxide can be used for delignification, high temperature peroxide. Oxygen delignification is an excellent chemical for this purpose, and ozone can be also used for delignification purpose. Hydrosulfite, FAS, DBI, those are not delignifying chemicals. They don't remove the lignin. Next process is the decolorization. All chlorine compounds, excellent decolorizing chemical. Hypochlorite, chlorine, chlorine dioxide. Peroxide is not that great chemical for decolorization purpose, but excellent brightening chemical. Oxygen, okay, not as effective as chlorine or hypo. Same as ozone. Again, hydrosulfide and FAS. They are not that effective as chlorinated compounds, but DBI gives much powerful because of various reductive species available there, bisulfite, borohydride, and also hydrosulfide. With respect to fluorescence, like I said, all chlorinated compounds can remove fluorescence. The only total chlorine free compound that can remove fluorescence is ozone. That's why people employ ozones if they are making food grade products. All these papers, OCC, office paper, color paper, everything is present in your bales. So you need to select what do you want to bleach. Do you want decolorization or delignification or brightening? Which is the dominant factor in your furnish? If you have a lot of OCC, you have brown fiber, you need delignification. If you have a lot of office waste with colored fiber in it with a lot of dyes, you need a decolorization chemical. If you have groundwood, then you need a brightening chemical. Now let's take a look at how do we optimize a bleaching process. There are various steps in a bleaching process: chemical charge, consistency, retention time, temperature, pH, where do we add this chemical, and pre-treatment, enzyme and chelate treatment. How do you optimize a bleaching process? First thing I would do typically is take your pulp and do a pH optimization. Use acid. Let's say your pulp is 7 pH available in a de-inking plant. Add acid little bit to go down to pH 6, add a little bit more acid to go down to pH 5. Add caustic to the pulp to go down to pH 8 and more caustic to go to 9. So now you have pulp from 5 to 9 pH. So what you do now is you add a particular charge of hydrosulfide or FAS or peroxide. Let's stay with hydrosulfide. Let's add 1% hydrosulfide on it at various pH. And then look at unbleached brightness and bleached brightness, see where it is at optimal level. Then choose that pH. That pH is good for your process. Now you selected the pH. We need to go back and select how much chemical you need. So take your pulp, adjust the pH to that optimum pH level. Now you add various level of hydrosulfide. 0.25%, 0.5, 0.75, 1% hydrosulfide on bone dry pulp. React it at that pH and look at the brightness gain. See where you get maximum brightness gain. Sometimes at 0.5 the brightness can level off. So you don't need more than 0.5% hydrosulfide in this case. Sometimes you need all the way to 1% to get your brightness up. That's how you do the chemical charge optimization. You can also, once you determine your pH, your chemical charge, now you can play with coolant, add some coolant, see whether you need coolant or not. If you get same brightness with and without coolant, that means your metal ions are already fixed or it is very low in your process. And also you can do time and temperature variations. Higher the temperature, shorter the time you need. So the brightness takes off much earlier, depending upon your process and depending upon how much energy cost you can survive it. So you can raise the temperature, shorter time, increase your production through the system. Or you can put in a reduction tower and let it sit at lower temperature for longer time to save your energy cost, but still the bleaching effect is the same. Pre-treatment, you can use enzyme and coolant. Coolants are used to fix the metal ions, enzymes are used to release the ink to brighten up the fibers. Point of addition, where do I add my chemical? Where is it optimal? In the case of news magazine, there is a factor called ERIC. ERIC is effective residual ink concentration. If you have a higher amount of ERIC in ppm, it can be measured with the brightness meters called ERIC 950 nanometers, it is measured. If you have a higher amount of ink particles, these are very small particles, ink. For example, 600 ppm here, you can see the brightness of that newspaper is very low. As you remove ink in your flotation cells and washing devices, you are lowering the ERIC, less residual ink is present on your paper, you are brightening the fiber. Okay. Why ERIC is important in bleaching? Let us take a look at here. Here it is on the x-axis, you have various dosage of hydrosulfide. On the y-axis, we have brightness. For various ERIC numbers pulp, 560 all the way to 150. This is the news mag furnish. When you have a higher amount of ERIC, you are trying to bleach carbon black, you are trying to bleach ink with the fibers. It is very difficult to bleach carbon black. The carbon black sites block your chemical, so it will not work on your fiber. That is why you get a very poor response. It is a flat line when you increase the dosage of hydrosulfide. As you remove the ink with the flotation step or washing, your ERIC goes down, you get a good response, quickly takes off. 2 to 3 points you get with hydrosulfide bleaching. So where in the process you add hydrosulfide? Typically you add at the end of the process, not at the beginning of the process where you have high amount of ink. So point of addition is extremely important for bleaching. These are typical metal concentrations in recycled fiber. As you can see in news and magazine, newsprint contains aluminum, calcium, some amount of fillers present here with the inserts, iron present, manganese. Iron or manganese, these are the two chemicals you need to watch for peroxide and hydrosulfide bleaching, and copper. If you look at magazine, look at that aluminum content. That is because of clay present in magazine, okay, aluminum silicate. And also higher amount of calcium carbonate present in magazine, you have calcium content is way high in ppm. Iron level is very high. So you can see magazine contributes quite a lot to the metals. And typically when you process through the de-inking process, when it reaches disc filter, from a particular mill I collected these numbers. The iron goes down to 236 from initial number of anywhere between 250 to 300. Manganese goes down, so as the copper. At the high D chest, again your metal content goes up compared to the press. This is because your paper machine water comes back and dilutes the pulp. We are bringing metal back into the system, and we bleach right there with the increased metal. So, we need to fix this metal with the key lens. This chemical table, this particular table shows various conditions I pulled out from the literature for various type of bleaching: oxygen, ozone, peroxide, chlorine dioxide, hypochlorite, FAS, hydrosulfide and borohydride. Typical dosages, temperature, time, pH and consistency. This is for your reference, a quick reference, how do I bleach with a certain chemical. Let us move on to recycle fiber bleaching process. A guideline is a combination of oxidative and reductive bleaching is beneficial. Oxidative chemical like peroxide followed by a reductive chemical like hydrosulfide or DBI is ideal in most cases, because if you do reductive bleaching first and oxidative next, the reduced chromophore sites can get oxidized, then color can revert back. It will drop your brightness. So, what you want to do is you do your oxidative first and then do the reductive next. And also it is a natural flow of pH down for your paper machine. From higher pH of peroxide goes down to pH of 7. If you are doing alkaline paper making or acid paper making process, you do not have to bring the pH down from all the way 9 to 4 or 9 to 5. All you need to do is from 5 pH or to 5.5 pH. Washing or neutralization step is very important. You need to quench that residual peroxide. You do not want oxidative chemical to go and eat your reductive chemical. So, you need a SO2 water for neutralization step or a washing step to take away the residual peroxide in the system. Now, here are the multi-stage bleaching typically used for bleaching fibers. PY, peroxide followed by hydrosulfide, is most popular for news magazine bleaching, also mixed office waste bleaching. YP is less popular, reductive first, peroxide next. In some mills they are using peroxide. Later on they realize peroxide is not removing color. Now they want to do a hydrosulfide bleaching. They may add Y bleaching front of the peroxide. PPY, peroxide followed by peroxide and then hydrosulfide. For additional brightnesses, particularly in the case of news magazine recycle, you need 65 brightness out of it. This process can be used. Or in other words, you can add little peroxide in the pulper for preventing alkali darkening and a regular standard tower peroxide bleaching, that is the second P, and the third one before the paper machine you add the hydrosulfide, that is the PPY process. Peroxide followed by FAS is used for mixed office waste. Peroxide followed by DBI is used for mixed office waste to make tissue and towel grade. Very most popular upcoming process. Now, let us take a look at color and fluorescence. Very fascinating world here, how they affect your bleaching process. More than 3,500 dyes have practical applications, but a small fraction of these dyes are used for paper making or paper coloring. Acid dyes, these are sodium salts of anions, which is a colorant. Basic dyes are salts produced by reacting organic base with acids. Direct dyes, sodium salts of anions, most popular direct dyes. So, you can see in this color paper, these are all chemical pulps dyed with direct dyes. Here is a red color paper and you have a yellow color, the telephone directories, a pink color and a blue color paper right there. These are all direct dyes. If you take a look at the various type of dyes and their affinity and retention, acid dyes no affinity for cellulose or lignin. When you recycle news magazine or when you are making newsprint, if you are making colored newsprint, then what you need is a basic dye, particularly telephone yellow directory. It's a CTMP pulp, yellow color, yellow pages in a telephone directory. That's a basic dye, basic yellow color dye used for that purpose. The reason you use a base dye is it has got good affinity for lignin, and in your mechanical pulp, when you make newsprint, you have very high amount of lignin, so lignin naturally takes the basic dyes. In the case of chemical pulp, like fine papers, there you add dyes, you use a direct dyes. It has got good affinity for cellulose and good solubility, medium solubility with water. Now, color of a dye is due to series of conjugated double bonds on the dye structure. If you have quite a lot of double bonds, you can get black color. The lower and lower the double bonds, you get red and again lower amount of colors present in the system, mild the colors. Most common dyes used is direct dyes. A dye is decolorized by a chemical agent by destroying the conjugated double bond. For example, here is a direct blue 218, and you have a nitrogen-nitrogen double bond azo group here. There is another azo group. All these aromatic rings are combined with this chromatic site. These are the color compounds. These are the color sites right there. The more number of color double bonds here, the darker the color you get. What you need here is when you use the DBI process, sodium borohydride, which can work on the conjugated double bond and split them into aromatic ring with nitrogen and another nitrogen with aromatic ring. So, the double bond is gone. The molecular chromophoric linkage of the color body is attracted by borohydride in this way. So, it becomes the color sites become colorless. This is how a decolorization process takes place. In the lab today, some students bleached a pink color pulp. This is how the pulp looks like in the process. Okay, it's
zoom out, not focus for that distance.
It's a pink color paper or pulp. When you try to bleach this is the hand sheet of that paper or that pulp. When we try to bleach this, it becomes white. This is DBI and hydrosulfide type of bleaching. What we are doing is the azo type dyes present here in this pink color. We are working on this nitrogen double bond nitrogen and cutting the double bonds to make it bright and white. The brightness here is 64, the brightness here is 85. The amount of dye removed is almost 95% between these two. You can see both right there. Here is a pink color to start with, that's a white color pulp. Now, what I am projecting is a Hunter LAB chart. On the x-axis, the horizontal axis, we have chromatic differences. In other words, when you have minus A is green color, plus A is red color. If you have plus B, it is yellow color, negative B is blue color. And on the vertical axis, you have lightness, darkness differences. When L value equal to 0, it is a black color paper. When L value equal to 100, it is a bright white paper. There are no color present in this. Its color value A and B values are 0. Look at that. It comes to the center. The value A and B are 0 right here. This is a brown paper here, like a OCC type paper. So, what is the objective of bleaching? Objective of bleaching is to remove the color. In a mixed office waste, you have multi-color present there. Depending upon what color paper coming into, if you have a lot of telephone directories, yellow pages, you are going to start with yellow color. A lot of ink like newsprint, flexographic ink, at the pulper it is going to look like you are going to start with the blue color fiber. Now, the goal of de-inking and bleaching process is to get to the center, make the color as close as 0, A or B value. You do not want to move to negative, because what you are doing is from pink color or red color, you are going to make the color to green if you move to negative. You want to go to the center and go as high as possible to make white color paper. This is an excellent diagram here to monitor your de-inking process. You can measure LAB values of before flotation cell, after flotation cell, before bleaching, after bleaching, and plot your data. And these LAB values will tell you how effective your bleaching chemicals are, and how high you are getting, and how good you are in removing colors to go to the 0 point of A and B values. The next tool we use here is with the LAB numbers called dye removal index. For example, in that color space, P1 is an unbleached pulp with L value, L1, A1 and B1 values. These are the color values of the P1 pulp. On the top, what you have is point of ideal bleach. This is that white color sheet of 100 brightness, 100 L value. Color value A is 0, B is 0. This length here is unbleached to point of ideal bleach. This is represented by R1. P2 is the pulp after bleaching with the values of L2, A2 and B2. These are the color values of the P2 pulp after you bleach with the hydrosulfite. Now, R2 is after bleaching, what is the residual amount of dye left in the system is the point of ideal bleach. Now, when you subtract R1 from R2, that is the amount of chemical or dyes you want to remove. So, what is the dye removal index? Dye removal index is nothing but R1 minus R2 over the original amount or the distance we need, original amount of dye present in the system. So, this distance over this distance gives you the dye removal index in a way, and we have given the formula for that for calculation of dye removal index. Here is what we call, there are different ways you can look at your color removal process in your de-inking system. Individual color differences, lightness darkness difference, unbleached L to bleached L differences, and unbleached A to bleached A, that is delta A, and the delta B is unbleached B to bleached B. You can also plot lightness versus chroma. Chroma is nothing but square root of A value differences before bleaching and after bleaching, and the B value differences before and after bleaching. Delta E is called color index. It accounts for lightness darkness difference and chromatic differences. So, you can see delta L, delta A and delta B differences whole square root gives you the color index. Next one is the fluorescence. What are fluorescent compounds? Fluorescents are the substances that absorbs light energy subvisible regions and re-emits in visible region. How do I measure fluorescence? With UV light. With the UV filter, with and without the filter, you measure the brightness difference, then it will tell you whether you have fluorescent whitening agents. Where fluorescents come from? The paper makers add fluorescent whitening agent in their process to get higher brightness. If they cannot achieve higher brightness after bleaching, they add little bit of fluorescent agent which goes in, absorbs UV light, re-emits at the blue wavelength of 457 nanometers, and it gives the brightness. Now, chlorine, hypochlorite, ozone, peracetic acid will decrease fluorescence. They will attack. Peroxide sometimes adds fluorescence. It can increase fluorescent chemicals. Hydrosulphide and DBI, they are neutral. They don't add, they don't decrease, or they don't increase fluorescence. The last thing is guidelines for recycled fiber bleaching. Let's say you want to bleach mixed office waste. We need to do decolorization and some amount of brightening. So, we need bleaching and color stripping processes. Multi-stage bleaching is required typically to achieve higher brightnesses. Pulper brightness is 60-66, as seen as low as 55 with more color. At the end of the process, you want to get a copy paper like 85 brightness or 90 brightness. How do I do that? If I have more ground wood, I need peroxide, a lignin modifying chemical, hydrosulfide. Oxygen and ozone can be used in the oxidative stage. FAS, hydrosulfide, DBI process can be used in the reductive stages. You choose, you don't need all the chemicals, you choose one oxidative, one reductive chemical. Most popular may be peroxide and hydrosulfide type of bleaching. Typical brightness gain, you can get as high as 10 to 20 points. It depends upon amount of dye. If you have only pink color present in the system, you can get as high as 20 points gain in brightness, just removing that dye, making that white bright paper. In the case of news magazine, you have more mechanical fiber coming in, less dyes. Some yellow color fiber, telephone directory is there. These are traditionally bleached with peroxide in the pulper and hydrosulfide at the end. Peroxide to the pulper prevents alkali darkening. You add caustic in the pulper to swell the fiber so that it can release the ink quickly, and also that caustic can react with amount of oil present in the ink as a carrier and do saponification, and it creates its own natural surfactant to give foam for the ink to come out. So, this peroxide, when you add caustic, the caustic can work with the lignin and make it darker, or called caustic yellowing effect. If you don't add peroxide, the brightness can go down. When you add peroxide, the brightness, it prevents yellowing of the pulp and it keeps the brightness up. And a pre-treatment of metal ions, very critical. Chelating agents, DDPA, you can add it in the pulper. I showed you how much aluminum, calcium, manganese, and iron comes with newsprint, particularly magazines. So, you need a chelating, DDPA or EDTA, you can add. And in the case of the news magazine, when you recycle, you need to watch out for catalase enzyme. It's present in the white water. If white water temperature is low, these catalase can go back. When the white water is going back as a pulper dilution water, this catalase can attack and take away your peroxide. You keep on adding peroxide, it does not help you with brightness because it gets decomposed to water and oxygen because of the catalase present. How do you take away catalase? You heat the water above 70 degrees C. Heat treatment is one way of getting rid of catalase, or there are some other chemicals available to take the enzyme out. OCC, old corrugated container. Now, let us take from brown fiber. I want to make white fiber. I need a delignification process because I have lignin present in that. Unless I remove that lignin, I am not going to make it white. So, you can cook it by Kraft process, soda process, or oxygen, multiple stage oxygen delignification. I have seen up to 3 stages. Then you can bleach with a multi-stage elemental chlorine free bleaching or total chlorine free bleaching. Chlorine dioxide, peroxide, oxygen, and ozone can be used to bleach these fibers. Again, OCC contains a lot of metal ions. Pre-treatment is absolutely necessary to complex the metal ions. In summary, recycled fiber bleaching is exciting. because it contains chemical fiber, it contains mechanical fiber, it contains brown fiber, it contains once bleached fiber. That's why it's called recycled fiber. It also contains dyes, ink, fillers, fluorescent whitening agents. All these compounds present in your fiber can make your bleaching challenging. So what do we need? We need multi-stages bleaching to take care of all these compounds. Oxidative and reductive bleaching processes, very useful. The chemistry, conditions and sequences and the stages depends upon what is the furnace you are starting with, what is the target brightness you need. Are you starting with Newsmax or are you starting with mixed office waste? Do you need 58 brightness or do you need 85 brightness? So depending upon that, you employ brightening chemical or decolorization chemical. Today, with the available bleach technology like peroxide, hydrosulphide, FAS, direct borohydride injection process, with multiple reductive species, you can handle lower quality paper grades, still get much higher brightness for copying paper. With that, the key references I used is the short course I had given in tapping, and also from Phil Cunett, bleaching and decolorization short course, and de-ink pulp bleaching by Dave Jane in 1996, recycling de-inking, CPPA. These are the notes I had taken. I compared their notes to prepare my presentation. Any questions? Again, my name is Mannar. I am the technical manager of the bleaching chemicals of Raman S company. My telephone number is 978-689-1591. My email address is mannar@romhas.com. You can contact me on my presentation if you have any questions. Thank you for your attention.